Welcome everyone. I'm going to introduce you our final report on our sentiment analysis on e-commerce women's clothing. In the presentation below, we will present our team's latest achievements in the sentiment research field based on feedback from our clients. After prior approval of our previous results, we were asked to analyze further in order to obtain new information. That information will help to achieve the primary goals of our client, which are increasing profit, reduction of waste, increasing customer satisfaction, reduction of cost. The process that brought us here is based on CRISP DM management method, and we can see how it proceeds in the chart. In the beginning, after receiving the order, we have got familiar with the data provided. Then after the entire process of digging into the dataset and after cleaning and preparation, we present our first progress. After making correction and rethinking the action plan, we were able to achieve satisfaction. Our team consists of Max, Dorin, and Neil, who this time took care of modeling, and Aneta, who will summarize everything for us. My name is Adam, and I will quickly remind us of the exact results and the process we've gone through so far. We decide to check whether the length of the given review has impact on the evaluation of a given product and consequently the recognition of the buyer sentiment. Logistic regression is the machine learning model that was used in the popular model classification and predictive analytics. The method tests different values in order to optimize for the best fit of the log odds of correction prediction. In this model, the coefficient is commonly obtained by estimating the maximum likelihood. After determining the coefficient, the algorithm computes the conditional probabilities to determine the maximum probability. In our case, we achieved the excellent results in predicting sentiment based on the length of the review after optimization. Using cross-validation, our pre-optimization model scored nearly 90%. Through cross-validation, the optimized model achieved 100% accuracy. Let's see how we can approach to the further analysis. I will pass voice to Dorin, who will start to explain our new models.
Hello everyone, my name is Doran and I'm going to be discussing some of the work that we did on our machine learning models in our initial phases. So we wanted to identify the sentiment of users' reviews in real time for our e-commerce business, and the model that we settled on was logistic regression. This is because it's used to describe data and to explain the relationships between some of the dependent variables and the independent variables of various types, and it's very good for doing this. So we wanted to investigate whether there is any impact of the testing sampling size on the accuracy of the model. So we built a testing pipeline, which will be able to run from a series of 5% to 30% testing splits. And from the results, we were able to also gather some information and measure the standard deviation of the different type of results. Now, it was pretty marginal, but we did notice that the 5% seemed to perform the best in this situation. And the 20% suffer the worst with the high standard deviation. This kind of suggests that there's overfitting issues with the 20% model. So we decided to go with a 5% test split. From the results, we gathered some error scores and developed an error score system where we're able to give it different scores depending on if it successfully or unsuccessfully identified an error. So it's very simple, basically 1 point for every successful prediction and minus 1 point for every false prediction. There was no bias for any type of error, and the final output was here. You can see on the right-hand side. It's in the form of a percentage, and this was done because the testing sample sizes of 5% is significantly smaller than that of 30%. So we just need to represent that as a percentage of its testing sample size rather than how many errors it got. We could see here that 5% actually did perform the best in correctly predicting the type of the errors, like minimizing the errors. So we wanted to optimize the model after this, after we settled on 5% test sample size, and we passed it through a grid search CV, which basically runs through all the different possible hyperparameters that are available for logistic regression, and it's able to run through all of them in a series and output the most optimal version of the logistic regression model. And here on the left hand side, you can see the optimal parameters. And this was able to significantly increase the model accuracy. So pre-optimization, the model accuracy was 88.64%, and after optimization, the model was actually 100%. Now, this is a little bit suspicious for us. For 100% is a bit too high, and the model is capable in our sample test to predict the sentiment 100% of the time correctly, but we wanted to investigate whether this is implying that there's some underlying overfitting issues with the model, if maybe some of the independent variables are too heavily correlated with our dependent variable. So we wanted to just go further into this, and this is what we explored in this semester. We wanted to go further into these results and verify if this is a model that we can present to our client for their needs, or is it something that we have to adjust and maybe pivot to a different type of model.
We then proceeded to use some additional machine learning models on our dataset, with the pipeline being prepared for linear discriminant analysis, K-neighbors classifier, and a decision tree classifier. From the previous analysis, a 20% training split was considered optimal and a 10 k-fold cross-validation was used. The pipeline results generated indicated a relatively high overall predictive accuracy of target customer sentiment, with the highest accuracy score being reported for linear discriminant analysis and logistic regression in this pipeline configuration. Classification tables detailing precision and recall scoring, as well as confusion matrices, were further evaluated for comparison across the algorithm results. LDA and LR logistic regression similarly performed better than K-neighbors and decision tree, with LDA having the highest recall score of 0.96, an indication of the total number of sentiment predictions correctly identified as positive out of total true positives. Linear discriminant analysis and logistic regression returned similar counts of false and true positives. Next slide. In further analysis, we gave consideration to the potential bias within our model training given the predominance of positive customer sentiment within our dataset, which accounts for over 78% of the dataset entries. We reran the pipeline analysis on a reweighted dataset where this dominant case was reduced so as to randomly and uniformly undersample it in equal proportion to the negative customer sentiment class. Those customers with negative sentiment are a key target for our business case use. The resultant improvement in model performance was highest in the linear discriminant analysis model, plus 0.55%, and the decision tree classifier, improving by 1.04%. However, overall, on balance, given the loss of information introduced into the dataset, with total customer sentiment observations being reduced by 79.5%, and the loss of other feature information, it is concluded that this trade-off is not warranted.
As we saw from the models that we performed last year, the classification and prediction of the sentiment analysis is the most important. We're trying to understand what, in our X variables, review, text length, class name, age, recommended IND, positive feedback creates an okay, good or great sentiment. For our project this year, we wanted to understand, in a deeper way, the clusters in our dataset. To do this, we use several different models, K-means, KNN, LDA, and the classification report. So, we are looking for the three classes of what makes an okay sentiment, a good sentiment, and a great sentiment. The first thing that we did was to run a K-means, which we used, and we used the elbow method to show how many clusters are in our data set. In the elbow method, we can see two creases on the graph, one at 2 and then one at 3. So we have a rough indication of the natural clusters within our data set. Next, we wanted to see how accurate our model was at predicting values that belong to certain classes. We used a KNN to do this, K nearest neighbor. Our accuracy for this model came back at 86%. And the confusion matrix showed that the true negative was the highest at 4,504. Then we used the decision tree. Again, we received a high, but it could be higher, a high accuracy score at around about 86% for the train and the test. Then what we did is we moved on to the Yellow Brick classification report. Again, for the classification, all of the great came in at very high, over 92%, 0.93. The good did not do particularly well, around about 0.25 for the highest and 0.3 and 0.5 for recall and F1 respectively. And OK did the best in recall. Then we went to the class prediction error, and this gives us a clearer image of how well great did. We can see the great clearly in the lead with over 4,000, while OK and good are both below 1,000. The ROC and AUC is to find, the goal of this is to find a trade-off between sensitivity and recall. As we can see for the ROC of OK, it's at 0.94. For good, it's at 0.75, and for great, it's at 0.88. These could be improved, but these are, in general, very good results.
In this assignment, we focus on further development of the machine learning part by running a few more machine learning models and dive deeper into sentiment analysis. Just a quick summary of last year's work, we wanted to see whether the length of customer reviews had any correlation with the overall sentiment analysis by using logistic regression, which is a model that is often used for classification and predictive analysis. The results that we obtained were predicting 100% of accuracy, which in real life is not ideal. In this assignment, we deploy additional models such as linear discriminant analysis, k-neighbors classifier, and decision tree classifier, and we were able to obtain results with accuracy score of for LDA 86.3%, KNN 75.6%, and decision tree classifier 79.3%, compared to logistic regression that had 86.1%. With these results, we can say that the LDA and our previous model, logistic regression, performed the best. We then focus on, rather than the positive feedback, on the negative sentiment of customers' feedback, as that could give better insight for future improvement to increase satisfaction of customers and potential sales and revenue increase. Out of 18,194 overall reviews, we only got 2,407 negative reviews, which makes up an overall of 13% of negative feedback, which is quite a satisfying result. What we did in this part was that we firstly balanced the data to avoid any bias toward positive sentiment. The reason why balancing our dataset is so important is because feeding imbalanced data to your classifier can make it bias in favor of the majority class simply because it did not have enough data to learn about the minority. In our case, we then work with 4,814 observations and run the same machine learning algorithms with a result of logistic regression 86.4%, LDA 86.9%, KNN 76%, and decision tree classifier 80.2%. Therefore, we can say that our models perform slightly better after balancing our data. However, as it was already mentioned, the reduction of overall observation was almost 80%, which is a huge decrease, therefore it is not really a great solution. What we haven't managed to do, which would give us better understanding and therefore develop insightful feedback to our client, was to perform a natural language processing model. It is usually used to understand and give a meaning of text documents such as social media comments, survey responses, or, like in our case, online reviews. The NLP features turn unstructured text into usable data and insight. However, given the complexity and difficulty of this much more advanced technique, it would require more time and further research to implement this. Therefore, we decided not to go with this method. And to conclude, we were able to implement and run various types of machine learning models, predict the accuracy, and compare each of the models to see which performed the best based on the sentiment analysis. Overall, we were happy with the achieved results and what we learned from this.